So, hello everyone, very good evening. I welcome you all at India's most comprehensive preparation platform for all competitive exams, that is BYJU'S Exam Prep. So guys, today we are going to discuss the questions of compiler design. So which questions? The questions which has been asked by IISC Bangalore whenever they have conducted the GATE exam. So let's start the discussion. This brief introduction of myself. My name is Vishal Rawatiya. I have 10 plus years of teaching experience and following are the achievements and areas of expertise. So this is my Telegram group. If you guys have any doubt related to GATE exam, or if you are finding any difficulty in understanding any particular thing, then you can ask me on this particular Telegram group. Okay, so there's an announcement that on 6th of September, that is on Sunday, Rakesh Talreja sir, 6th on September, Rakesh Talreja sir is going to conduct a workshop that how you can score 13 out of 13 marks in engineering mathematics. Now, apart from that, BYJU'S Exam Prep is going to conduct a national scholarship test on 10th of September. If you do good in this particular test, then you may avail up to 90% off on all our programs. So, to participate in this particular workshop, you can download the BYJU'S Exam Prep application. The link is present in the description. Okay, so let's discuss the very first question of the compiler design. Very easy topic. So first of all, you just need to understand this is the most scoring subject. Why? I mean, I'm not saying that there will be too many questions from this particular subject, but the idea is whenever a question comes, you will be able to solve the question of this particular subject if you have given a maximum of 50 hours to this particular subject. So 3-4 marks in 50 hours is good bargain. Okay, so let's start. So match the following. So there is P, Q, R, S are given, which are representing lexical analysis, top-down parsing, semantic analysis, and runtime environment. You just need to see that which particular thing is used for what purpose. So lexical analysis is done using what? So what is the idea of lexical analysis? We need to generate the tokens, and to generate the tokens, we need to match the pattern of a string available in the high-level program with the patterns of the predefined token. So whenever you want to match the pattern matching is done with the help of regular expression, pattern matching. For pattern matching, you will require the finite automata, and for that pattern, you will represent the patterns in terms of regular expression. This is the concept of TOC, but compiler design and TOC will go hand in hand. So you cannot say that, okay, sir, I know one subject, but I am not covering the another one. Don't do it. I mean, okay. Now, when say top-down parsing, so there are two parsers, top-down parsers and bottom-up parser. Top-down parser uses what? Leftmost derivation. Bottom-up parser uses reverse of rightmost derivation. Yes, so this. So this one is with respect to P, this one is with respect to Q. Semantic analysis is used for type checking. So up to syntax analysis, you will check whether the string can be generated or not. Then you will see that the string which we have generated is semantically correct or not. So that's the type checking, that is R. And runtime environment. In the runtime environment, the overall memory space, let's try to understand this. In runtime environment, the overall memory space is divided into code area, data, some space is given for the stack, and some space is given for the heap. So heap is used for dynamically allocated data structures, and stack is used for the keeping track of a thing that at a particular point, which particular procedure is being executed. So stack is used for the purpose of recursion, and if you are executing a particular procedure, then you will push the activation record of that particular procedure into the stack. So at the runtime environment, the terminology among this four which is associated with the runtime environment is this activation record. So sir, what is this? P3 is only this P3, Q1, R2, S4, right sir? So option B is the correct answer. Okay, damn easy, right? If you have the basic concept, theoretical question, most of them will be theoretical. I don't know why, because IISC did not ask any question related to concept of parser. I was just looking at the questions for the very first time. I realized that IISc did not ask the questions from the parsing, from the parser. So, I mean, there is a question, but it's actually a theoretical question. It is not using the concept which we discussed in the chapter parsing or syntax analysis of the compiler design. So, what does it say? An LALR parser for a grammar G can have shift reduce conflict if and only if. So, there are two statements that, what do we say? Shift reduce conflict. What happens with respect to LALR1? So LALR1 is generated by the DFA of LR1 items. So if you take the full construction of LR1 items, then you will have the CLR1 parser. Now there are two things, that one is SR conflict, another is RR conflict. So in CLR1 parser, if SR conflict or RR exists, SR or RR exists, then it is guaranteed that it will also exist in LALR, because in the overall full item set, Rahul sir, for statistics, wow, good, you can promote here, come on. Okay, so in the CLR1 parser, what do we do? Sir, we generate the DFA of LR1 items. In LALR1 parser, what happens? In the DFA of LR1 items, if there are two or more states which differs only in their look ahead, then we will merge those states. That means that in LALR parser, number of states may be equal to CLR1 parser, or number of states in LALR may be less than CLR1 parser. Now, in the complete set, if SR or RR conflict exists, then it is guaranteed that SR or RR conflict will also exist in LALR parser. But opposite, let's try to understand. If SR conflict exists in the LALR parser, then it is guaranteed. If SR conflict exists in the LALR parser, then it is guaranteed that SR conflict will also exist in the CLR1 parser. I hope you understand that concept. What is needed for A implies alpha dot A whatever beta at T1. Let's assume B implies gamma dot. So these are two things, and these are two things. This is one item. This is the item in CLR1. Please try to understand. This is in CLR1. Another, I can directly give you the answer, but please try to understand. If you are looking at from the conceptual purpose, then you should know this. Alpha A beta comma T2. Let's say that this is T3, and let's say that this is T4. So B implies gamma dot. We are saying CLR1 parser. So in CLR1 parser, if there is no SR conflict, then what is the situation? That this terminal A does not belong to T3. A does not belong to T3. If A belongs to T3, then there will be SR conflict. We are saying that in this state also of CLR1 parser, there is no SR conflict, means A does not belong to T4. A does not belong to T4. What will happen when we merge them? If we merge them, the state will be what? The state will be A implies alpha dot A beta, and this will become T1 union with T2. Whatever the terminals are there in the T1 and whatever the terminals are there in the T2, they will be merged. And B implies gamma dot. With respect to this, it will become T3 union with T4. Please try to understand. If A does not belong to T3 and A does not belong to T4, then we can safely say that A will not belong to T3 union T4 as well. A will not belong to T3 union T4 as well. Means if there is no SR conflict, if there is no SR conflict in CLR1 parser, then there cannot be SR conflict in LALR1 parser. So if SR conflict exists in the LALR1 parser, then it is guaranteed that that SR conflict will also exist in the CLR1 parser. So LALR1 parser for a grammar G will have shift reduced conflict if and only if CLR1 parser has the shift reduced conflict. So by default we write CLR1 is the LR1. So LR1 parser for G has SR conflict. Option B is the correct answer. Obviously. Clear? Let's look at the third question. Which of the following describes a handle? What is an handle? Handle is actually used when we understand the concept of bottom-up parsing. What happens? Sir, we start from the given input string. We start from the given input string. Let's assume the string is something x, 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 x. I think that most of you have seen this particular example, x, 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 y, z, z वाला जो example है. So, what do? We scan this string from left to right, character by character, and whenever we find something which matches with the complete right hand side of our production, then we will reduce that particular thing into the non-terminal on the left hand side. Clear? That's the idea. So this is the concept of handle. Handle is basically a thing which matches with the complete right hand side part of our production in the grammar. So if there's a production in the grammar, A implies x, x, y, x, x, y. So when we see from left to right, x, x, let's assume that nothing else is given. So x, x. Now the moment you see x, x, y, then you have seen x, x, y, which matches with the complete right hand side part of the production. Therefore it is an handle, and it can be reduced into this non-terminal A. It can be reduced into non-terminal A. Got the idea? So this is an handle, and basically it is used for what, sir? LR parsing. LR parsing uses what? Reverse of rightmost derivation. So the sentential form, what do I mean by sentential form? When you are deriving the tree, then whatever the sequence available at the terminals of that tree or at the leaf nodes of that tree at each step of the construction is known as a sentential form. And because it uses reverse of rightmost derivation, therefore we say right sentential form. What do we say? Right sentential form. They will not use this term, but anyway, just the understanding that handle. So what is an handle? Handle is nothing but a substring which matches with the complete right hand side part of the production. That's the normal definition. Let's try to understand with respect to these statements given in the option. It is a position in the sentential form. Is it a position? That third position or fourth position or fifth position? No, sir. It is a position in the sentential form where next shift or reduce. No shift. No shift. If there is an handle, then you will reduce. If there is an handle, you will reduce. So this reduce will not be there. It is a non-terminal. It is a non-terminal whose production will be used for reduction in the next step. No. Why non-terminal whose production will be used in the next step? No. It is a substring. Please try to understand that this substring, when you are looking from left to right, what will happen? You will keep pushing. First of all, you will push this x into the stack, then you will push this x into the stack, then you will push this x into the stack, then you will push another x into the stack, then you will push y into the stack. So basically, this is the viable prefix. If any substring of this viable prefix matches with the complete right hand side of part of the production, then that will be an handle. That will be an handle. So it is a production that may be used. It is a production that may be used for reduction in a future step, not in a future step. If you have obtained an handle, then and there you will perform the reduction. It is a production that may be used for reduction in the future step along with a position in the sentential form where the next shift or reduce operation will occur. No, nothing is related to next shift or reduce. Look at this option D. They are not giving the direct definition, but they are trying to say the exact same thing which we are defining. It is the production that will be used for reduction. This is a production which will be used for reduction in the next step. In the next step itself, if you have obtained this handle, then the next step itself you will perform the reduction along with the position in the sentential form where right hand side of the production may be formed. So wherever, at whichever position you find the right hand side part of the production at that particular step, you will eventually reduce in the next step, and that portion, that portion which is matching with the complete right hand side part of the production is known as handle. So this definition which is given here is not appropriate. This definition which is given here is not appropriate because the definition of handle is simple, that in the sentential form, the substring that matches with the complete right hand side part of our production will be called handle. So that's it, simple. But you can actually see that these two definitions which I am giving and which is given in the option D are quite same. The only thing is that they have described too many things. That it is a production with respect to which we will perform the reduce action in the next step along with the position in the sentential form. Along with the position, so at whatever position we get the substring which matches with the complete right hand side part of the production. Gets it? So option D is the correct answer. Option D is the correct answer. Let's look at the damn easy question. But if you are not thinking properly, you may give the wrong answer for this particular question. Why, sir? Because you don't need to use the, you cannot use the general programming language precedence and associativity if it is exclusively defined in the question. In the question, it is saying the attribute of the three arithmetic operators, what are the operators? Plus, minus and subtract in some programming language are given below. It is saying generally what do we say, that asterisk will have the highest precedence, but here it is saying that plus will have the highest precedence, then minus, then asterisk, and all these are left associative, but here it is defining the subtraction as a right associative. Here it is defining the subtraction as right associative. So let's try to understand what will happen. Sir, what is the, we generally use Bodmer's principle, but here we need to use the precedence based on this order, So first of all, the operation with the highest precedence will be performed. So highest precedence is for addition. So first of all, you will perform this thing, 5 plus 1. That's the one thing. Then what? This is the first thing. Then what? So the next, any other addition here? No, sir. No other addition. Then after that, you will have a subtraction. After addition, the precedence is for subtraction. Now there are, what will it become? So after this addition, it will become 2. 5 plus 1 will become 6. This will become minus 7 into 3. Now what? Sir, it is saying that this subtraction is a right associative. Means the subtraction which is on the right hand side. If there are two consecutive subtractions, A minus B minus C, then generally we perform A minus B and then we perform C. But if it is right associative, then we will first perform B minus C, then we will subtract the result from A minus. So first of all, we will perform this. That's the second thing, because it is right associative. So what will it become? So after that it will become 2 minus 6 minus 7 is minus 1. 6 minus 7 is minus 1. Then 3. Then again you will perform this. 2 minus minus 1 will be 3 into 3. Now this is the final thing which you will have in hand. So the last precedence is for multiplication. The only operation available is the multiplication. Therefore we will perform the operation and the result will be 9. Clear? Clear? So if you are first thinking that I will multiply 7 into 3, then I will write 21, then don't do it. Okay. So whatever precedence and associativity is given in the question, you will have to use that precedence and associativity. Clear? Next question. Oh, this is again, what does it say? Consider, here you will get the idea of handle. In this particular string, I will give you the idea of handle. So consider the following syntax directed translation scheme with non-terminals S and A. These are the only two non-terminals, and A and B are two terminals. So these are the productions of the grammar using the above SDT, whatever that S implies AA. Whenever you reduce with respect, what happens in the SDT if you are using that SDT with the bottom up parser? Whenever you perform a reduce action, the corresponding semantic action will be executed. Now the string given is AAB. The string given is AAB. So please try to understand the concept of handle also. So first of all, what will we do? Look at this. First of all, we will see this A. Does this A matches with the complete right hand side part of any production? Yes, sir. This A matches with this S implies A. Therefore, this A, the moment you see this A will be reduced in S. So whenever you are reducing with respect to S implies A, the very first thing that will be printed is 2. The very first thing that will be printed is 2. Then what will happen? Does this S matches with the complete right hand side part of any production? No, sir. So have you seen the complete string? No, sir. Next input symbol is not dollar. Otherwise, if it is the starting symbol and the next input symbol is dollar, then you are done. You have generated the string. Clear? But in this particular case, next input symbol is not dollar. Next input symbol is A. Now what? Let's read the next terminal. SA. Does SA matches with the complete right hand side part of any production? No, sir. This does not matches with the complete right hand side part of any production. So I hope A to A, then this A will come here. SA does not matches with the complete right hand side part of production. But does any of the substring of this matches with the complete right hand side part of a production? Yes, sir. What? So this A, please, I'll explain that what is the problem here. I explain that what is the problem here. This A will again become S. So what do you have? Because of this, you will again print 2. Because of this, you will again print 2. Good. Then what? Sir, SS, and then none of the substring of SS matches with the complete right hand side part of the production. Therefore, you will see B. Now, is there any substring of SSB which matches with the complete right hand side part? Yes, sir. SB matches with the complete right hand side part of the production. Therefore, it will become SS and you will print 3. So, you may say, sir, that it will print 223. You may say that it will print 223. But please try to understand that how do you derive this string from this particular grammar? How do you derive this string from this particular grammar? So, first you will have to see that it is a bottom-up parser, so it will use reverse of rightmost derivation. So here S will eventually expand. S can eventually expand into AA or something is wrong in the question. Something is wrong in the question. S implies, is this, something is wrong in the question, because all of them are A, so this A will never get absorbed. This A will, capital A will never get absorbed. So please give me a second. Let me correct the question if there is any error. Just 1 minute. Let me correct the question if there is any error. And obviously there is an error, because if we take it as it is, then it will create problem. If we take it as it is, it will create problem. Yes, sir. There is a change in the question. What? So this is capital A. This is capital A. This is not S, this is capital A. Obviously, because otherwise A will become unreachable. Otherwise A will become unreachable. Non-terminal, this non-terminal A cannot be used to derive any string. So that's it. Sorry guys. Problem in the question. Sir, what were you trying to do then? Here, what were you trying to do? There are some situations when a string can be parsed using LR parser, but sometimes it may be parsed using CLR1 parser, but may not be parsed using LR0 or SLR1 parser. In those situations, you will have to choose that when to shift and when to reduce. So the best approach will be that starting from the start symbol, try to derive the given input string, and using, how do you derive this? Try to derive the given input string using the rightmost derivation, and then scan it in the reverse. So consider that this is your grammar and I want to generate AAB. So one thing is sure, that this B must come in the end. So what will we do? So we'll say S implies AA. Please try to understand. This is the first expansion. First of all, we'll expand S by AA. Then we'll expand this A by SB. We'll expand this A by SB. This is the second expansion. And then we can expand this S by A. And this will give you the string AAB. This will give you the string AAB. So this is the derivation of this string AAB using this grammar while we are performing the rightmost derivation. Just in the opposite sequence, the things will happen in the reverse of rightmost derivation. So let me explain that what will happen in the reverse of rightmost derivation. It is AAB. So you will see this A, you will see this A, but the moment you see this A, you will try to reduce it into S. If you reduce this A into S, if you reduce this A into S, then SA will not match with anything. This AB will come, this AB will come. So this SA will not match with anything. This will become SB. This again SS will not match with anything. This SB will again match with A, but SA will not match with anything. So that's the problem if you use it directly. So first try to construct the tree. First try to construct this tree. In tree, you know what? Sir, when we are trying to generate this given input string, the last expansion that will happen is S implies A. The last expansion that will happen is S implies A. Therefore, the first reduction that will be performed is that this second A will be reduced into S. So when the second A reduced into S, that will be with respect to 2. So the first thing that will be printed is 2. After that, this SB will be reduced into A. So when SB reduces into A, then the action which you need to perform is this 3. So the next thing that will be printed is 3. Then you will have AA. Then this AA will be reduced into S. When you reduce AA into S, the third thing will happen, that is you will print 1. So please, there is a problem. Let me explain. This handle, generally we believe that when we say LR0, please try to understand. If the grammar is LR0, if the grammar is LR0, it will not worry about look ahead. So in the LR0 grammar, the moment you see a substring which matches with the complete right hand side part of the grammar, it will be an handle. It will be an handle. But if the grammar is a if the grammar is an LR grammar but not LR0 grammar, then you may have to see that what is the next look ahead. You may have to see that what is the next look ahead, and based on that look ahead, your reduce actions or shift actions will be performed. So the idea is, if you actually know the concept, then AAB is the string. The moment you will say the moment you will see this A, you will try to reduce this A by S. You will try to reduce this A by S. But if you reduce this A by S, please try to understand. If you reduce this A by S, then what is the next input symbol which will follow? So the next input symbol that will follow is the terminal A. Now look at this particular grammar and tell me whether non-terminal A belongs to follow set of S or not. Belongs to follow set of S or not. So what is the follow of S? What is the follow of S? Sir, follow of S is nothing but S is the starting symbol, therefore dollar is obviously, and then no. Another follow of S is B. So the only two terminals which can follow the non-terminal S are dollar and B. So you will not reduce A into S if the next input symbol is A. You will reduce A into S when the next input symbol is either dollar or B. So when you reduce this is A into S, the next input symbol is B. So this will not be correct. You will be able to reduce this A into S because the next input symbol is B, and that can eventually follow the non-terminal S. Therefore, this will not be reduced, though it matches with the complete right hand side part of production. But when you think about all different parsing algorithms, you will know this basically, we know that we are only looking at the follow set. Therefore, this grammar is SLR1. By looking at the string, you can eventually determine that this grammar is SLR1, because when you are taking care of follow set, this string can be generated. If you are not taking care of the follow set, this string cannot be passed using LR0 LR0 parser. So this is SLR1 but not LR0. The given grammar is SLR1 but not LR0 because we need to take care of the follow of the non-terminal when you are reducing a terminal when you are reducing a handle into corresponding non-terminal. Clear? So this is it. I mean, ultimately the string first needs to be generated by the grammar. How the string will be generated starting from the starting symbol, this is the manner in which the string will be generated. So this is the rightmost derivation. Obviously, this is the rightmost derivation as well as leftmost derivation. Why? Because at every sentential form there is only one non-terminal. Therefore, that will be leftmost non-terminal as well as rightmost non-terminal. Clear? So this is the idea. This is both, but obviously this satisfies the constraint provided by rightmost derivation. So if this is a rightmost derivation, then the last expansion will be reduced first. So this S implies A will be reduced first. So S implies A is print 2. Then SB will be reduced second, and A implies SB is 3, and finally AA will be reduced into S. So S implies AA is 1. Therefore 2, 3, 1 is the correct answer. No rocket science, but it's just that whether you understand the concept of different LR parsing algorithms in a better way or not. Okay, sir. 6. Okay, there is a question from SSA. Consider the following code segment. These are the codes. The minimum number of total variables required. Total how many variables are required at minimum to convert the above code segment to static single assignment form? SSA. What is SSA? Sir, every variable must be defined before it is used, and there cannot be more than one assignment to the same variable. That's the concept, right? So when you see x implies u minus t, so some of the things can be, please try to understand this. U minus t, y equals to x into v. This x will be y plus w. This y will be t minus z. And this y will be x into y. So can you actually see that there are multiple assignment to the same variable? Yes, sir. This x is assigned twice. This y is assigned 3 times. So it should not happen. So what will happen? So let's assume that this u and t are assigned from the, or these are basically coming from outside. So you can actually use u minus t as it is, or you can see that u and t are assigned externally. Then u minus t, then this x1, let me call it x1, that the result of u minus t is stored in x1, and this u and t are defined from outside. There is no problem if you define them internally also. Let me define them internally. So that let's assume that u1 is initialized, then t is initialized into t1, then the result is stored in x1. I can also write like this. Clear? But so you have initialized u1 and t1 once. Now what? Sir, then x, you need to use this x. So it's not an assignment, it is the u. So you can use this value of x1. Then v. This v is also assigned x from outside or defined from outside. That's one thing. Now here also you can say one thing, that this x1 is already defined, so I can use it. But this v is not defined, so I can first define it as v1 and then I can use it. So if something is coming from outside, then you can actually use it directly, or you can define it in a new, define it within the code, but both of them will produce the same result. And then result needs to be stored into y. So let me call it y1 in both the cases. That this is the first assignment of variable y. This is the first assignment. So that's what am I trying to signify using this 1, 2 or 3? I am trying to signify that this is the first assignment, second assignment, third assignment, etc. So this u1, t1, v1 are the first assignment, or you can say u1, t1 and v1 are being defined for the first time. Then what, sir? Y. So what y, sir? The last result will be used. So obviously y1 is defined, so y1 plus w. So w is also coming from outside. W is also coming from outside. Now it needs to be stored in variable x. It needs to be stored in variable x. You have already used this variable x1, therefore you cannot store this result into x1. You will have to use another variable x2. So this is another variable. Now similarly, this y1 can be used directly, but if you want to define this w internally, you can define it as w1. And again, the result needs to be stored in a new variable, because the you have already initialized x1 once. You cannot reuse the same variable. Clear? Then comes t minus z. Now please tell me, we have defined this t once. We have defined this t once. So can we use it again? Yes, sir. We can use it again. Uses can be repeated, but the assignment cannot be done more than once. Assignment cannot be done more than once. So t is fine. Then z. Okay, sir. T minus z. So obviously this z is also being defined from outside. Here also you can write that this t1 can be used and this is z1. Clear? Now t minus z or t1 minus z1 is the same thing. You may say that, sir, we have already used t1, but it is being used. You have initialized t1 once and you are using the same value. You are not assigning a new value to the same variable t1. That's the concept. Now this result needs to be stored in y, but we have already used the variable y, therefore you will have to use a new variable y2. You will again have to use a new variable y2. That's okay. Then finally x. So sir, the last definition of x is from here. So last definition of x is x2. Last definition of x is x2 and this y is the last definition of y. So the last definition of y is y2. Right? And you need to perform the multiplication. And the result needs to be stored in y. But again, y1 and y2 cannot be used. You need to use a new variable, that is y3. Clear? So if you look at this code, how many variables are there? How many variables are there if you convert it into static single assignment form? Sir, u, t, v, w and z are assigned from outside, and the new variables which are initialized are x1, y1, x2, y2 and y3. So overall there are 10 variables which will be needed. Overall there are 10 variables which will be needed if you convert this code into SSA form. Clear? Sir, here also t1 z1. Now you can actually see t1 minus z1 you need to store into y. Now you have already used y1, so you will use y2. Here you will use x2 into y2, you will assign it into y3. So either you can use u1, you can use u, t, v, w, z from outside, or you can initialize them within the code and you can use the variable u1, variable t1, variable v1, variable t1, variable z1 and variable w1. So same t1 therefore will not be counted twice. Same t1 therefore will not be counted twice. I have explained it in a proper way in a video. So if you guys are not comfortable with the concept of SSA, then you can watch that particular video. Okay. So total minimum number of variables needed will be 10. You can actually see this 5 from external, 5 new. So overall 10. This is the answer for question number 6. Let's move to the next question. Some code optimizations are carried out on the intermediate code. Why do we perform the code optimization? That's what is being asked. They enhance the portability of the compiler to other target processor. Is it so? Is it so that the code optimization are carried out on the intermediate code because they enhance the portability of the compiler to other target processor? Maybe. See, why do we generate the 3 address code? We generate the 3 address code so that there's an intermediate form. There's an intermediate form which can be converted into target code based on the machine. That if you have one processor, so let's try to understand. This is your intermediate. So generally your idea is to convert this high level language into low level language code. Clear? Now, sir, first of all, we'll convert this high level language code into intermediate form. And this please, let's look at this. Why this intermediate form? Because the machine for which you need to convert this high level language code need not be same. You may want to convert it with respect to machine 1, you may want to convert it into low level language with respect to machine 1, you may want to convert it into low level language with respect to machine 2, you may want to convert it into low level language with respect to machine 3, etc. So there may be various machines. So if you start from the beginning, it will become difficult, because from high level language, if you do not generate this intermediate code, Then for machine M1 you will have to start from the beginning. For machine M2 also you will have to start from the beginning. For machine M3 also you will have to start from the beginning. But if you generate an intermediate code, then what will happen? This intermediate code will be same for all the machines, whether M1, M2 or M3. So if you have generated this high level language, if you have converted this high level language into low level language with respect to machine M1, and in between if you have defined this intermediate code and somebody asks you to convert this high level language program into low level language program with respect to machine M2, then you will not have to start from the beginning. You can simply convert this intermediate code with respect to machine M2. Means the translation from high level language to intermediate code will be machine independent. So obviously they enhance the portability of the compiler. What is the, intermediate code generation will enhance the portability of the compiler to the other target processor, but it is not the task of optimization. It is asking related to optimization. Why do we need the intermediate code? We need intermediate code so that it will become portable to compile the given program with respect to different target processors or different machines. But optimization is a different aspect. So please try to understand. Program analysis is more accurate on intermediate code than on the machine code. Is it so that program analysis will be more efficient, more accurate? No, it's a vague statement. Now, the information from data flow analysis cannot otherwise be used for optimization. The information from data flow analysis cannot otherwise be used for optimization. What is this? It is asking some code optimizations are carried out on the intermediate code. Why? The information from the front end cannot otherwise be used for optimization. Okay, so that's the idea. Please try to understand this. None of them looks correct at this point of time, but we need to reread the question to make it interpretable. Some code optimizations are carried out, some, not all. It is saying some code optimizations are carried out on the intermediate code. That's the language. I guess I did not understand the language correctly in the first time. So there are two different types of optimizations which can be machine dependent, which can be machine independent. So if you are trying to perform the optimizations which are machine independent, then you can eventually convert that optimized code into target code with respect to different processors. So yeah, it enhances the portability of the compiler to the another target processor. Good enough, right? Program analysis is more accurate on intermediate code than on machine code. No, sir. It depends on your analysis construct, how well they are defined. So you can perform the program analysis on the intermediate code as well as you can perform the program analysis on the machine code, but it does not mean that it will be more accurate on the intermediate code. It will be more accurate on the machine code because you are performing it with respect to that particular machine. Clear? The information from data flow analysis. What is data flow analysis? That how data will flow. So we eventually generate a control flow graph in which we will see that what are the variables which are live, what are the variables which are not live. That is known as data flow analysis. Cannot be otherwise used for optimization. So is it so that we are performing the optimization on the intermediate code, but it is saying in the opposite manner. We are eventually performing the optimization on the intermediate code so that it becomes easy to generate, it is easy to convert it into target code with respect to different machines. But this optimization has to be machine independent. The information from data flow analysis cannot be otherwise used for optimization. What is it trying to say? That whatever information you are getting from the data flow analysis cannot be used for optimization if you do not perform this optimization on the intermediate code. No, sir. So the information from the front end. Front end means up to intermediate code generation. After that, once you start generating the target code, it will become back end. Okay. The information from the front end cannot otherwise be used for code optimization. No, sir, these are all the vague statements. Please try to understand why are you performing the optimizations on the intermediate code. Why are you performing these optimizations on the intermediate code? Why are you not performing those optimizations on the final target code? We are not performing the optimizations on the final target code because if we perform the optimization on the final target code, then that particular optimization will be specific to that machine only. Will be specific to that machine only. Therefore, the correct answer will be option A. Clear? Let's look at the next question. So I have not defined the options for this particular question A, B, C, D because the space is not sufficient. Anyway, this is very clumsy. So which of the following are true? A programming language which does not permit global variables. Theoretical question. A programming language which does not permit global variables of any kind has no nesting of procedures or functions, but permits recursion can be implemented with static storage allocation. क्या बोल रहा है ये? A programming language which does not permit global variables of any kind. So this is a program in which all the variables are local variables, none of them are global variables, and it does not require the procedures or functions. It does not require the procedures or functions, but permits recursion. But permits recursion can be implemented with static storage allocation. Can be implemented with static storage allocation. No, sir, you are not having any global variable. You are not calling procedures or functions. You can eventually use stack, but the idea is if there is any dynamic data structure which is being used, then it will not, you will not be able to allocate the memory to the dynamic data structure if you use static storage allocation. So dynamic storage allocation is also needed in the form of heap. Clear? So this statement is not correct. Second, multi-level access link or arrangement is needed. Multi-level access link. Why do we use the access link? Access link is used to access the variables which are defined externally, right? So multi-level access link is needed to arrange activation record only if the programming language being implemented has the nesting of procedures or functions. Yes, sir. If there is nesting of procedures or functions, then ultimately you may use the variable which is defined by some other procedure if you want to call them. If there is no multi-level nesting, then what will happen? If there is no nesting of the procedure, that one function cannot call another function, then for a function, the variables will be local. It will not have to access any global variable. In that particular case, you will not require the multi-level access link. But here it is saying multi-level accessing arrangement is needed to arrange activation records only if the programming language being implemented has nesting of the procedure functions. Yes, if there is nesting of the procedure functions, then the variables which are defined in some other procedure, to access them you need to provide the access link. Yes, sir, this one is correct. This one is correct. Recursion in programming language cannot be implemented with dynamic storage allocation. Can we do this? Recursion in programming language cannot be implemented with dynamic storage allocation. The stack can be implemented dynamically also. So no, right? Nesting procedures or functions and recursion require, what does it say? Nesting procedures, functions and recursion require a dynamic heap allocation scheme and cannot be implemented with state-based allocation scheme for the activation records. Is it so? Tell me. Nesting procedures or functions, basically a function calling another function, requires a dynamic heap allocation scheme. And do they require dynamic heap allocation scheme? And cannot be implemented with a stack allocation scheme. Can they not be implemented with the stack allocation scheme? Please tell me. This is the concept. Why do we use the stack when you are using the concept of nested procedure calls or recursion? Then to implement the recursion, you will require the pushing of activation record into the stack. ये क्या बोल रहा है? And cannot be implemented. It says it cannot be implemented. Is it so that it cannot be implemented? I don't think so that it cannot be implemented. It cannot be implemented with stack based. Sir, it has to be implemented with stack based. Yes or no? So nesting procedure functions, no sir, this one is wrong. Programming languages which permit a function to return a function, programming language which permit a function to return a function at its result cannot be implemented with a stack based storage allocation, scheme for the activation record. Tell me, what does it try to say? Sir, if a programming language is allowing a function to return a function as a result, so what you are returning is a function, so it again needs to be executed, cannot be implemented with the stack based storage allocation scheme for the activation record. Yes or no? Yes or no? Sir, if you are permitting a function to be returned as a result, then it becomes complicated, because if you are using stack based storage allocation, then sir, this is the idea. In stack, this function f1 calls another function f2 and it is returning another function x. It is returning another function x to f. Then how do you execute this? Because this function x which is returned, should it be executed then and there? So you have returned it. Now how do you call this particular function? So in a stack based storage allocation for activation record, you cannot do this or you can do this. Yes sir, it cannot be implemented with the stack based storage allocation scheme for activation record. Only the stack based allocation scheme. Clear? So this statement is also true. So what are these statements? Multi-level access link is needed, and programming language which permits a function to be returned cannot be implemented using stack based storage allocation scheme for the activation record. You will require some other things as well. Clear? So this is it. Sir, from which compiler designing section this question is based on? This is based on the concept of runtime environment. This whole thing is based on the concept of runtime environment. Very rarely such type of questions will be asked. So please try to understand the options for these questions are of type like 2 and 4, B is 3 and 5 and 6. It can be anything. So this is basically an MSQ also. This can also be an MSQ. So all these things are related to what? I don't know whether you understood it or not, but let me explain that all these things which are being discussed are related to the concept of stack based allocation and heap allocation. So that's the exact same thing which I explained, that during the runtime, the memory space will be allocated to a process. Code and data will be, for code and data, the space will be allocated statically, but there will be some space which will be allocated for the implementation of runtime stack and for the implementation of the data structures for which the memory needs to be allocated at the runtime. So these are the two things. These two things will grow in the opposite direction. Now, why do we use the stack? Why do we use the heap? That's the inner level knowledge. We generally no one has ever asked a question of this particular type. Now it is IISc, so they can ask anything, right? So it is the internal detail, that why do we use the access link, why do we use the return field in the activation record, etc. Right? So that's the idea, that in the activation record we also have a return field. and it will eventually represent that when you return a value, where exactly you will return that particular value. But it says a programming language. Generally, if you are trying to return a simple value, it can be done using static storage, stack-based allocation. But if you are trying to return a function, then this thing will not perform well. Clear? So, I mean, this is something very different. So this question is obviously, I can understand that many of you, or what do I say? If I ask this question in the MSQ form, then don't worry if you guys are thinking that, sir, we are not understanding this particular question in a proper way. Then my guarantee is that 95% of the student will not be able to score the positive marks in this particular question. Obviously, if it is an MSQ, there will be no negative, but 50% of them will fail to give the correct answer for this particular question. So no worries if you guys are thinking that this question is difficult. Some of them or basically it is a question which is designed so that you will waste a lot of time and you will score some negative marks. That's it. There is no other feeling in the designer of this particular question. He just wanted you to waste some time, and he actually wanted to analyze that how well have you studied the concept of runtime environment. So generally, very few questions are asked from this topic of runtime environment. So we only try to understand one thing, that what are the different fields in the activation records when a memory is chosen from the heap allocation, when actually the memory is allocated from the stack area. That's what we need to discuss. Generally, the question will consist of only that information. But this is eventually a deeper level question. So that's okay. Not a problem. Right? So the correct answer will be option 2 and option 5. This is it. Oh, sorry. So please join this Telegram group if you have any doubt related to GATE exam. That will be all. Thank you very much. If you like the video, then please hit the like button. If you are new to the channel, then subscribe for the channel and press the bell icon to get the notification about upcoming videos. Take care, keep learning, prepare hard.